So far, we have already seen many errors: missing files, wrong key, wrong types, syntax mistakes. So today we are gonna take a brief intro into error handling. Real programs often receive input from users. Users can type anything. Instead of numbers, letters, or instead of letters, numbers, invalid text, unexpected values. So the program needs to account for situations going wrong in order for the program not to break. Let's do a little example. So let's say we have a little program like this. So we ask the user to enter his age, and if we enter 30, here we go, print 30. But what happens if the user enters text, breaks, value error? So this is an example of a value error. Let's create another simple error. Print 10 divided by 0. And then let's just add another line. Print, we are on the next line. If we run all, when we are on the first line of code, creates an error. Now it's a more specific, or specifically a zero division error, because we tried to divide by 0. So it does not, the program breaks and it does not run this line. So Python allows us to handle these exceptions without the program breaking. So the syntax for that is like this. Try. We try to print. It's got a squiggly line. Why? Try statement must have at least one except or finally. Okay. So except. Now let's run all. So here, tried to print 10 divided by 0. Since it threw an exception, it ran this line in the except clause and printed error. But then it went through and executed the next part of the code. So this is why error handling is very important. We can go specific and catch here only the zero division error. And if this is a zero division error, print dividing by 0 error. Run all, here dividing by 0 error. But now if the user inputs not a number and the letter divided by 2, because this depended on user input, and we run this, now it will throw an error because the except was specific. If we remove this, now it caught an exception, printed the error, and run the next line, but we don't know what error it threw. So let's do another example of another type of error. With open missing CSV because this file here in our file system does not exist. Print read file. So if we run all of this, it now throws at us a file not found error. So what if we try with open except file not found error? There, now it printed file not found and run the next line. As you can see, there are many different kinds of errors. So now let's do a little real life example. Suppose we want the user to enter a value, and so to prevent user entering text or symbols or empty values or anything else except for a number, and we prepare for this. So let's start with the little example. So a while loop, while true. So this will run forever. So unless we break out of it, right? So we are going to do it bounty equals int input enter bounty. Print valid bounty. And if we are running this line, oh, I'm sorry, I missed the try. So we try to convert the input and assign it to bounty. And if this line was run, it's going to print this, right? And if this has gone right, let's break out of the loop. Except value error, we are going to print please enter a real number. And this is it. Now the program becomes more robust, because if the user enters Luffy, please enter a real number, random-ish, just enter without anything, and until we enter a real number, valid bounty 3000. And this little pattern appears very constantly in programming: validating the input, retrying, handling unexpected values, and preventing a crash. So that is it for this video. Hope you enjoyed it. Thanks for watching. See you on the next one.